In this lesson, we're going to look at normal distribution and z-scores. In the last lesson, we learned about what z-scores are. Now we're going to use our calculator in order to draw the curve and plot our z-scores on there. And from there, we can figure out some information that doesn't only land on the specific scores that we're finding, but maybe also in between those intervals. So for example here, we've got a z-score of 0 that goes in the middle. That's our mean. 1, 2, and 3 standard deviations above the mean. 1, 2, and 3 standard deviations below the mean. Okay? It says given a z-score, we'll use our calculator to find the area under the curve. We already know how to find the area for z-scores of 1, 2, and 3. And that was our previous lesson. Find the probability that a score lies in the interval from -2 to 1. Well, from -2 to +1 would be all in here. Now, we want to find out what the area under the curve is. Well, from our normal distribution lesson, we know that there's percentages that align with that normal curve. If we look back at the diagram, we can see that from 0 being there, right, 1 here, -1, and -2, if our z-scores were plotted in there, and we highlighted from -2 to 1, the same way we just did in our notes, that would be this area under the curve. Now, because these line up right on the z-score lines, right on those specific intervals, this is actually a sample of an example that we can figure out by hand. We would just add the 34% plus the 34% plus the 13.5%. We want to see that we can do this as well using our calculator. So let's go back and see how this would work using our calculator. And then we're going to look at, well, what happens if we're not going from -2, but maybe we're going somewhere in between -2 and -1, up to a point that's not exactly at those intervals. All right, let's go back to our notes. All right, so if we did this by hand, the percentage would be 81.5%. If we were asked to find the probability, we would say that that would be 0.815. And if we were asked to find the area, that would also be 0.815. So read very carefully and see what exactly it is that we're being asked to solve. Now, let's do this with our calculator to ensure that we're getting the same answers, and we know how to do this with our calculator so that when we're in between the intervals and we can't do this by hand, we still have a tool that we can use to solve these questions. Method A is using shade norm, and method B is using normal CDF. This is my preferred method just because it takes less time and it ensures that I understand the concepts, and shade norm is a little bit finickier. I would like to show you how to use both so you know that you have those tools. All right, it says here that we go into our calculators and we put in second vars draw 1. Okay, now when you're doing that, okay, that's going to give you shade norm, and you're going to put in your minimum score. So our minimum score in this case is -2. Then comma, our maximum score, that would give us 1. And then it wants our mean and our standard deviation, right? Well, our mean for z-scores is always going to be 0, and our standard deviation for z-scores is always going to be 1. Okay, so that's not going to change. So all we need to do is put in our min score and our max score. So in our case, that would be -2 and +1, and then we put 0 and 1. Okay. Now it says you must clear the drawing after every use, and this is how we do that. Second, program 1 and enter. Now our window is going to have to be set specifically as well, and our window needs to be set like that so that we can use and see what's going on in our calculator. Okay, so let's go ahead and give this a try. Alright, now that I have my calculator out here, I'm going to click on window, and I've gone ahead and put in all of those window settings that was given on my notes. So my x min is negative 4.7, x max is 4.7, and so on. Okay, so now what we're going to do is we're going to go to second vars, right? And we'll get this menu. And we're going to go to draw, so arrow over to draw. And you can see here we've got shade norm is the very first setting, so click on 1. So again, now this is where we're going to put our minimum score of -2, comma, our maximum score is 1, our mean is 0, and our standard deviation is 1. Then you're going to close that. Once you're done that, you can hit enter. So what you can see here is a diagram, exactly like the one we've already drawn in our notes, and they've shaded the area from -2 to +1. They've also given us the area as 0.818595. Now if we go back to our notes, and look at what we did by hand, 815, there it is. Okay, so the calculator is more accurate because it has more decimal places in there, but that's exactly what we had done before. Alright, so let's just write some notes out. So shade norm, like we said before, this finds the area, and this shows the graph. Okay, whereas when we're doing normal CDF, it just finds the area. So there's no graph. So that's the other thing, because for all of your questions, I am going to ask you to draw a diagram. So if you like to see the diagram given by the calculator, then you can go ahead and use shade norm. Now, what did we do here? To find the area and the graph, we cleared the drawing, then we set the window, and then we put that in, and our picture looked exactly like what we had up there. This is what I would expect you to draw. -2 to 1. I usually put in the 0 too, just to give us a sense of where we are. And then you're going to shade all of that, right? Oops. So when you get a question like this is what you're going to be showing for your work. You're going to do your diagram, show me where you're shading, because that's the area, and you're going to tell me that the area is 0.818595, because that was given in our calculator. Alright, let's try this again using normal CDF. So normal CDF, you're doing the same thing. You don't have to worry about the window because you're not drawing. You're going to have a minimum score, maximum score, same as before. So you would put in normal CDF. My min score is -2, my max score is 1, 0, and 1. So you'd write that into the calculator, and it will give you an area, and it should give you the same area that we got before. So let's go back in here. We're going to go back into second. Where am I looking here? Looking right here. Second vars 2. So lots of places to go to. Same vars menu, but you're going to go into 2. Now I'm saying vars menu, but it's actually not. If you look above vars, when you hit second, it's DISTR, so that's a distribution menu. So you're going into the distribution menu, and you're going to go to number 2, which is normal CDF. Don't confuse that with 1, which is normal PDF. So 2, and then you're going to put in the same -2, 1, 0, 1, close the brackets, enter, and it gives you the answer right away. So you don't have to worry about the diagram. You do, however, have to draw it. Okay? So not having seen the diagram, you need to know what you're drawing, which I like because it makes sure that you understand what you're drawing here. Make sure that you understand the concept. So we're going from -2 to 1. You'd shade that. Show me that this is the area that we're representing, right? From there, from -2 to 1. And you tell me that the area that we get, rewrite that, 0.81859. Now you can keep going. Usually I tell you what to round to, but this is what my calculator gives me, 818,594,6784. So that's how we can do this in our graphing calculators. Let's take a look at example 7. In example 7 here, we're going to look at all the different types of questions that you're going to be asked. So given a z-score, find the area. So for each of the following, find the area under the curve, which is the probability, and sketch the resultant area. When a maximum or minimum score is not given, we use the highest score, E99, or the lowest score, negative E99, that the calculator will allow. So essentially what we're saying is we're going to infinity, and that's how you put it in your calculator, or to negative infinity. I'll show you how that looks. Now it says this is obtained by the key second E99 or second negative E99. We'll have a better look at that once we find an example where we have to do that. So for A here, it says find the area under the curve where the z-score is greater than 0. So how I start these questions, because I'm going to use normal CDF for all of these, how I do these questions is I first start by just drawing the diagram. So what does that mean? Okay, well let's just draw the bell curve. Now 0, I know, is in the middle here, right? That's 0. So it's saying that we want a z-score greater than 0. Well, z-score greater than 0 would be anything in this region here. Well, I know that that should be 50%. If I know that's 50%, I can write that down as an answer. But let's see how to do that in our calculator. Okay, so in our calculator, we would put in normal CDF. My minimum score is 0. But what's my maximum score? Because I'm going all the way to the very end. Well, this is the case where you're going to infinity. So we're going to put in E99, and I'll show you how to do that. My mean is 0. My standard deviation is 1. All right, let's try this out. So I'm going to clear my other stuff out of here. And I'm going to go into second vars, or the distribution menu, go to normal CDF. So we know it's going from 0, comma, and do you see above the comma there's that double E? So we go second E 99, and then comma 0, comma 1. Enter. So there we go, 0.49 repeated, which is exactly what we anticipated. That rounds to 0.5 or 50%. So that means an area or a probability of 0.50. All right, let's try that for B. So B says Z is greater than 1.67. Well, if I draw my normal curve again, right? Here's 0. Where's 1.67? Well, if this is 1 and this is 2, 1.67 would be more than halfway, right? So I use another color here, 1.67. So I'm going a z-score of greater than 1.67. So if I were to shade that, if I use another color here, if I were to shade that, that would be everywhere in here. Okay? So how do we do that in our graphing calculators? That would be normal CDF from 1.67 to infinity, or E99, 0, 1. Punch that into your calculators. Second vars, 2, 1.67, E99, 0, 1. Enter. You get 0.4745 and so on. So let's just round that to 0.047. Alright, now that you're starting to get a hang of this, I'm going to do one example and then I'll give you the answer to the next example. And if you want, you can hit pause and try the second one on your own. So for C here, it says our z-score is less than 0.42. So what would that look like? Do our diagram first. I know this is 0. right? So 0.42 would be between 0 and 1, so a little bit higher, 0.42. So we're shading less than 0.42, so that would be everything over here. Normal CDF, that would be 0.42. Well, wait a moment, why would that make sense, right? So when we're doing this normal CDF, the first value is not the maximum value, and in this case we can see that 0.42 is the maximum value. So how would I write this now? Well, I'm going from negative infinity to 0.42. Well, negative infinity is negative E99 to 0.42, and then 0, 1. So the difference between the example that we're just doing and the ones we were doing before, we had the minimum value was given to us and we were going to infinity. Where now we're starting at negative infinity and we're going to 0.42. So try this one out in your calculator. Second vars, or the distribution menu, normal CDF, negative E99 to 0.42, mean of 0, standard deviation of 1, and enter. And you can see that the area under the curve would be 0.6628 if we round to a 4 decimal place. Alright, go ahead and try D. Same idea. You're going to find the area where Z is less than negative 2.57. So go ahead and give it a try and come back and check with my answers. Alright, so we're going from negative infinity to negative 2.75, and you can see that this is a very, very, very small area. Negative 3 would be even further, right? We know the area for negative 3 is 0.015. So this is just a little bit bigger than that. And when you look, okay, you can see with our normal CDF, now that was 0.015% when we figure out the normal distribution where it goes from negative infinity to negative 3, right? That's that part of the curve. 0.0000015 would be the area. So here for this example, our area is 0.00508. So it makes sense that that value is so small, but a little bit bigger than what we would have anticipated if it was negative 3. Now let's look at example E. Now you can look at E, F, and G, and they're all a little bit different because you're not only given just a z-score above and a z-score below, but in E, for example, you have 2 values. So what exactly does that mean? Let's try to draw the picture first. So if I draw my normal curve here, it says the z-score is between negative 1, okay, so if this is 0, this is negative 1, and 1.9. So if this is 1 and this is 2, then 1.9 would be a little bit smaller than 2, right? We would like almost at 2. So the area that we're trying to find is right in here. So how does that look in terms of our graphing calculator? Well, we would put in normal CDF. Our minimum score is negative 1. Our maximum score is 1.9. And our mean and our standard deviation don't change. So that's actually not too bad when the area is between a lower limit and a higher limit. Okay? Punch that into your calculator. So we would have our lower, which was negative 1, our upper, which was 1.9, 0, 1, enter, and you get an area of 0.8126. Okay, if we asked for the probability, you would give the same value. If I asked for the percentage, it would be 81.26%. Go ahead and try F on your own and see if you get the same answer as me. Alright, so our area is between negative 1.73 and 1.73, and you can see our area is 0.9164. Okay, so that's covering the majority of that curve. Alright, let's take a look at the last two examples. We've got G and H. How are these different? Well, it says that the z-score could be greater than 1.75 or less than negative 1.75. So if I were to draw this, what would that look like? Well, here's 0, here's negative 1.75, here's, oops, it should be symmetrical, so positive 1.75. But the area isn't between. The area is greater than 1.75, which would be all of this, and less than negative 1.75, which would be all of this. So essentially, we have to do this twice, right? We would have our normal CDF from negative E99 to negative 1.75, and that would give us this area, and then we would do it again. Oops. And this time it would be from 1.75 to E99, 0, 1. And then we would take our two answers and have to add them together because we're finding the area of each side separately. Now the nice thing in this case, 1.75 and negative 1.75, those two values should be equal. So if you figure out 1, you can multiply it by 2, right? So let's have a look at what the answer is for the 1. So I go into my distribution, normal CDF. If I go from negative E99 to negative 1.75, I get a value of 0.04006. And that would be the same here, 0.04006. So if I add those together, the total area, right, adding those two values together, would be 0.08012. Okay? If you recognize that they're the same, you could just do it once and multiply it by 2. Alright, go ahead and try the last one. Now, once you've tried it, come back and check with my answer and ensure that you did this one right. Alright, for this example, you should have noticed that you weren't able to multiply this by 2 because both sides were not equal, so you had to do them separate and then add them together. Thanks for joining me today.